Now, I worked out the solutions myself more thoroughly rather than just give you the textbook answers because we're reviewing, and I thought that was a good idea. Okay, so here you're finding the measurement of the line segment XZ, which is what that symbolically means, the measurement of line segment XZ. So you combine 17 and 24. Whereas here you're finding the measurement of line segment XZ as part of a larger value, 38. And so you would subtract here, 38 minus 27. Okay, and then, we didn't really go into some of the properties as thoroughly, but if you want to know, you can do number 7 and 8 because of something called the segment addition postulate. Okay, and here, plotting these coordinates, so I went ahead and just did this here just to get a visual. And one of these wound up being a vertical line, and the other wound up being a horizontal line. Okay, so that means we can find the horizontal line just by subtracting, and we can do the same thing with the vertical line. So the top y minus the bottom y, 1 minus the negative 3. You could also think to go from 1 to 0, and then go from 0 to negative 3, 1 plus 3. And then for A and B, the x on the right was 8, the x on the left was 3, so 8 minus 3, and those two line segments were not congruent because 4 does not equal 5. Okay, and then here, it's just a matter of taking the coordinates they give you, using the midpoint formulas. So you add the x's, divide by 2, you add the y's, divide by 2, and I just left it as a fraction. And then getting the distance formula. So I did the right x minus the left x, the right y minus the left y. And be careful, because if you're minusing the negative, that could cause a goofy error. Right? And so this is what wound up happening. 1 squared plus 1 squared is 1 plus 1, and then the d squared equals 2. So we take the square root of 2. And the same thing with 15. Well, no, wait, what am I thinking? 11, 12. I wonder why I stopped at 11. Huh, interesting. Looks like I had a brain freeze. I didn't do 12 and 13. Interesting. Well, maybe because it was the same thing as number 11. All right, well, anyway, so here I plotted the coordinates for these two problems. And 14, you got a rectangle with horizontal and vertical sides. And 15, you had a right triangle that had the legs as horizontal and vertical sides. So that makes it easier to get the distances of the sides, just like the warm-up. Okay, and so then now the area of a rectangle, once we know the length times width, and then the perimeter, since there's two sides with a 3 and two sides with a 7, it's a little easier to calculate. Whereas with the triangle number 15, okay, we can get the two sides of the legs, and that's all we need to do if we want to get the area. So the legs were both 7 and 7. So 1/2 base times height, 1/2 7 times 7. But with the hypotenuse, the side we tend to call C, we had to do the Pythagorean theorem. And then once we get that missing side, we can add that to the other two sides to get the perimeter of this right triangle. Okay, and then for the rest was based upon angle properties. So with 16, they told you the larger angle, the measurement of the ABC was 77. So that means the two smaller angles are going to combine to equal 77. We can't assume the two smaller angles are equal to each other because we're not given any reason to believe that. And so when we write this equation, we have the two expressions for the two smaller angles added together to equal 77. Once you solve that, you get x. And then we want to find out what the measurement of the two smaller angles were. So we substitute the x value of 9 into the two expressions to get the measurement of the two smaller angles. And then the 17 is the same thing. They gave you the larger angle measurement of ABC, 111. So the two smaller angles would add to equal 111, solve the equation. And then once you get the x, you substitute into the two expressions to get what the measurement of the smaller angles are. Okay, and then 19 was just, if it's complementary, subtract from 90. If it's supplementary, subtract from 180. So 19, 20, 21, 22 were not quite as involved. Now, 18 was asking you to get the measurement of that angle that they draw there. Now, you probably weren't going to be able to do that. Not a big deal if that was an issue. But what I did is I went ahead and I took a picture of this. So with a Mac, you can take a screenshot. So you can see what just happened, and then I can kind of squeeze this over and then capture it, which I won't do. But on your end, you could also do the same thing I'm going to show you. So I got a picture of that. And then I went to the online protractor, and I'll just show you what I did just for the sake of it. So if you want to go there, you could also type in the Google online protractor. All right, so I'll go ahead and renew this page and show you what I did. So when you get here, you can upload an image and it'll put the protractor over the image. So that's what I did. I'm going to browse, and then I'm going to go to the picture I took. And notice it puts the picture right there, but that's too small. So I'm going to go ahead and bump up the size. That's much preferable. And then I'm going to go in right here and move the protractor so that it's on the corner and on the baseline. It can be a little finicky, but then I'll click up over here right above the protractor, and it'll give us a little line that we can use. And right about there appears to be okay. So this is certainly bigger than 180. So it's between 130 and 120, and it looks like we go 1, 2, 3 back from 130. So that would be 127 degrees, roughly 127 degrees.